In this problem, we're going to address area and volume again, so let's take a look at it. It's a calculator OK problem. Let region R be the region in the first quadrant bounded by the x-axis. So that's the bottom here. And the graphs of y equal ln x and 5 minus x. Well, ln x is obviously this curved part over here on the left, and 5 minus x is over there on the right, as shown in the figure above. Find the area of region R. So you could integrate this with respect to x. If you're going to do that, you're going to have to switch over at this x value right here where I've drawn the vertical line from ln x to 5 minus x. So for part A, the answer for part A is going to be the integral from 0 to whatever that x value is, which we will find in a moment, of ln x dx minus the integral from that value to x equal, well, let's see, 5 minus x is going to cross the x-axis at x equal 5 there. So to 5 of 5 minus x dx. Now to find x, you're going to set the natural log of x equal to 5 minus x and plug that in your calculator, and you will get an x value of 3.693. So those are your limits of integration. 3.693, 3.693, and you will find that this answer is approximately 2.986. So let's take a look at the scoring on that. You get 1 point for the integrand. Notice they integrated with respect to y. You do not have to do that. You could integrate with respect to x. Oh, actually they showed that right here. The limits of integration and the final answer. So 3 out of the 9 points there. In the next part, part B, it says the region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. So basically you've got a square here, and we'll call that area A of x. And that area is going to be the upper function minus 0, or just the upper function, squared, because we're going to take the length of this side and we're going to multiply it by the length of that side to get the area. So for part B, the integral from 0 to 3.693 of ln x squared is the area of that square, dx, plus at 3.693 x value, we're going to transition to a different upper function, 3.693 to x equal 5 of 5 minus x quantity squared dx. And that's all we have to do for that. So let's take a look at the scoring. 1 to A, natural log of x quantity squared dx, and A to 5 minus x quantity squared dx, and they pointed out that A was equal to, up here, 3.693. So 3 more points for a total of 6 of the points so far. I'm sorry, I mislabeled that last part A, and I meant to call it B. Part C. The horizontal line y equal k divides R into 2 regions of equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. So I'm going to illustrate this here in green. Somewhere in here there's a horizontal line y equal k that divides this into 2 equal areas, the green and the blue. So we need to write but do not solve an equation involving one or more integrals that finds that value of k. So what we're going to have to do is we're going to have to integrate with respect to y. And again, this y value, if you found that on your calculator, turns out to be 1.307. The line y is equal to 5 minus x. If you solve that for x, turns out to be 5 minus y. And the curve y is equal to ln x. If you solve it for x, x turns out to be e to the y. So we are going to evaluate the following integral. Integral from 0 to k of greater function minus lesser function. So greater is the furthest to the right. 5 minus y minus e to the y dy is equal to the integral from k to 1.307 of 5 minus y minus e to the y dy. Let's take a look at the scoring for that. 0 to k, 5 minus y minus e to the y dy is equal to 1/2 times the total area, which that they got from the first part. That actually could be found the way we found it as well, by integrating from k to 1.307 5 minus y e to the y dy, which is another option for that.